well. This is how to make compost. In order to make good quality compost using a thermophillic process, you need three things. You need the ingredients, you need the method, you need the containers. Now those first things that you need is a nice mixture of both easily digestible and less easily digestible material. There's a huge amount of scope, but today I've actually got the best of materials. So this is how to make the best compost with the best materials. These materials being horse manure, grass cuttings, waste straw and seaweed. Now, as I said, as well as the ingredients, the container to do it in. Now here are the containers. These are bins made out of recycled pallets. It's based on the New Zealand box concept, and what you can see here is each bin is approximately 2 square meters, so that you can make a heap of 1 square meter, as has been made here, make a heap of 2 square meters. So that's the. Now these bins are constructed in a way that they both allow airflow and insulate the. And perhaps down the back here you can see it best. So that in this way the air can flow in through here and then through the gaps here, here, all the way down, and particularly at the base. If you look at the base, you can see there's quite a large gap, and at the same time the heat is kept in by the inner side as well. Now this has been built so we can actually get air flowing all the way through the whole system. Right, here we have a single 1 square meter heap that was built. Right, here we have the heap, and there's the original layers. Now I'm going to open this up and we'll see how much heat is in there. And this particular heap, as I say, was built on Christmas Eve. It's now the 2nd of January, so it's approximately 10 days old. So the centre of this should be roasting, which it will be hopefully when we open it up and see how hot it is. Oh, that's pretty hot. Yeah, it's definitely hitting 70s. Absolutely boiling in here. Now I've got a thermometer. This is roasting. That's lovely and hot, especially on a cold day like today. So that's hitting a temperature in excess of 50 at least, if not 60. And what we actually want to do anyway is we want to ideally hit a temperature between 60 and 70, optimum 65, for approximately 3 days. In this way, if we can get this to hit 60 degrees for 3 days or more, it'll destroy all weed seeds, human and animal pathogens. Nothing survives that. And this is the trick with making good compost, is getting this initial heating stage off correctly. That's why this specific heap's been built. This heap was built as a starter heap for these two main ones, and also to ensure that this size will cook up, and as you can see it is cooking up pretty well. As I haven't got a thermometer with me, but the hand test says it's at least 50. Right, this is the heap we're going to build. Now in here I put a layer of straw, just broken up very roughly. In fact, things unbroken a bit better. But if you take some of this waste straw that I've got, it's already got fungi attack on it, it's pretty spoiled. Just break it up. Don't do any trampling or pushing the stuff down. The weight of the material you put it on will do that, and you want to try and trap as much air as possible. So once we've just opened it up a bit, let's spread that over, give you a rough layer, and on the surface of that we're going to put some of the compost from that small starter bin. The stuff I turned out, what I'm going to do, sprinkle it across. The very top of that last heap was covered in straw to help insulate it. But inside it's a mixture of materials that I'm using today. Mainly horse manure, seaweed, horse manure and straw. I've made this starter just so we can really get a good microbial count off into the heap, because the trick here is getting this thermophillic to bloom as fast as possible without the temperature exceeding 70. If you start to exceed 70, you actually start to destroy the mesophiles, which is the second stage that you need to concentrate on. You can see on top of that layer of starter compost, I put a layer of seaweed. And what I'm going to do now is I'm going to add one of the most important ingredients to get this to work right, which is gypsum. Now if I just pop this back here, what we're doing is going to cover it with gypsum, and the purpose of the gypsum is that it does three things for you. The first is that it will help displace any salt that happens to be on the seaweed. This has come from the sea, there's a degree of salt on it. It's not enough really to be worried about. I mean, it's a very minor aspect there. Second aspect of the use of gypsum is that it will react with ammonia to form ammonium sulfate. So instead of this ammonia coming off as a nasty smell, any ammonia that's in here is converted into ammonium sulfate and remains then within the heap. Third reason for using gypsum, and this is generally the main reason why gypsum is used in compost making, is to prevent it from going slimy. Gypsum helps it to flocculate. It's very common in mushroom farming, and it's often used as a clay breaker. Now gypsum has other properties which is useful. I mean, it's a quite common mineral, mainly composed of calcium sulfate but also magnesium sulfate, and the magnesium and the calcium ions are available. The interesting thing is, because of the sulfate ion, the pH isn't raised. Right, so let's get some gypsum on. And this looks like grey cement, because it's actually what a lot of cements and plasters are made from. But it's also used for plaster of Paris, but it's a very pure form, whereas this, the agricultural form, is impure, and those impurities actually have benefit, because as I say, the impurities are with magnesium sulfate, and plants need magnesium as well as calcium. So that's a layer of gypsum put on. Now the next thing to do is put another layer of waste material. So what we'll go for, I think, is some of the grass cuttings. Alright, here we go. So here's the layer of the grass clippings. So I'll start off, and what you do is you just layering it across the top, keeping the, no pressure, just allowing it to settle on top of each other. The point behind this is that what we're going to try and do is we're trying to create an environment, the optimal environment for the microbes to flourish. And in order to do this, they need three things. Everything always comes down to trinities, I'm afraid, isn't it? They need a food supply, they need water, and they need oxygen. And those three combined give them the environment to grow. So the food supply in this case is the straw, the manure, the seaweed and the grass. This particular is pretty wet, so we don't need to add too much water. We will need to add some. We're building a kind of a cake with these stacked layers, lots of air and moisture trapped in them. And as the structure and texture of the material is attacked by the growth of thermophillic bacteria, it will collapse and shrink. Anyway, so as I said, get that layer on. Hopefully that tape's still running. It's a bit lumpy. Any lumpy bits, just try and break up, but without pushing the compost down. So you've got a nice even sort of layer there across the top. I mean, the thickness should be somewhere between 2 and 6 inches, possibly 4 inches of material. If you actually squash it down, it would actually squash down to less than half an inch. Because you're keeping it open, souffle style, then that's that bit done.